Sorry for the late start. We're just going to wait a few minutes and see if anyone joins us. Let's see here. This is the first time I am doing it via Streamlabs and YouTube, so I need to get some background sound music from the other computer. So there we go. So okay. So okay. So Amateur Extra. We are going through the ham study questions via because they have, when you get them wrong, they have some explanation that you can read right associated with the question. So that is what the plan is there. And so let's get started, and I will see if anyone wants to join us. Please click the StreamYard link that I have posted in the that I have pinned to the top of the comments, and I will bring you in. Let's see. I will try to keep an eye on the questions as well. So if I don't let, yeah, anyone have any questions over there, feel free to ask as well. Let's get started. Which of the following is an acceptable bandwidth for digital radio medium, DMR based voice or SSTV transmission made on the HF amateur bands? A, 20 kilohertz, B, 10 kilohertz, C, 15 kilohertz, D, 3 kilohertz. I'm going to go with 3 kilohertz. That is correct. The answer is D, 3 kilohertz. And my mic was down, and you probably could not hear anything. Let me just verify my sound a minute. How is my sound looking? That looks good. Okay. So, first question is what the question was, what is the following, which of the following is an acceptable bandwidth for DMR based voice or SSTV digital transmissions made on the HF amateur bands? And just because of HF is single sideband, which is approximately 3 kilohertz. That is the answer I went with, D, 3 kilohertz. How do ALE stations establish contact? A. ALE state radios send a constant tone to establish a frequency for future use. B. ALE radios monitor an internet site for the frequency they are being paged on. C. ALE radios activate when they hear their signal echoed back and scatter. D. ALE constantly scans a list of frequencies and activating the radio when the designated call sign is received. I'm going to go with the longest is the correct answer. So I'm going to go with D. And that is correct. So again, welcome to all those viewing later. I try to do a amateur extra study session every Sunday. Please like my channel, click on the notification to get an alert when I go live. And yeah, hopefully you can join us and everyone has good success studying. The next question is which of these feedline impedance would be suitable for constructing a quarter wave Q section for matching a 100 ohm loop to a 50 ohm feed line? A, 450 ohms, B, 62 ohms, C, 75 ohms, D, 50 ohms. From memory, I remember we had this question and it was 75 ohms. If I'm correct, to get the answer, you take 100 times 50, take the square root of 100 times 50. And it comes in right in the neighborhood of 75 ohms. What core material property determines the inductance of an inductor? A, the permeability, B, the resistance, C, the thermal impedance, and D, the reactivity. And that would be permeability. Permeability is a measurement of the response of a given material to a magnetic field. How is positive feedback supplied in a Kelpit oscillator? Through A, through link coupling, B, through tapped coil, C, through neutralizing capacitor, D, through capacitive divider. And I think I've gotten this one as well, so I think it's through the tapped coil. No. And I was wrong. It is D, through a capacitive divider. Think C for Colpitts and on capacitor. And voltages supplied by dividers. Why is de-emphasis commonly used in FM communications receivers? A, for compatibility with transmitters using phase modulation. B, to remove third order distortion products. C, for higher efficiency. D, to reduce impulse noise reception. I'm going to guess B, and I am wrong. And that would be A, for compatibility with transmitters using phase modulation. So let's see what they say on the de-emphasis means attenuating higher received frequencies by the amount by which they were boosted prior to transmission. The purpose is to improve signal to noise ratio. Phase modulation inherently emphasizes higher frequencies at 6 dB, requiring PM receivers to de-emphasize the signal upon reception. What is the function of hysteresis in, and I'm mangling that pronunciation, in a comparator? A, to increase the sensitivity. B, to allow the comparator to be used with AC input signals. C, to prevent input noise from causing unstable output signals. D, to cause the output to change states continually. And I'm going to guess C, to prevent input noise from causing unstable output signals. That is correct. And why I guess that one is because hysterias sort of sounds like hysteria, like you're going crazy. And so I took the one that mentions being unstable. So we have a ground or a antenna wave signal, wave propagation. What is the elevation angle of peak response in the antenna radiation pattern shown in E9-2? So the peak is going to be really low down to the ground here. So this is 30 degrees, this is 15 degrees. Half of that is 7.5 degrees. So I'm going to take the one that is 7.5 degrees. Next question. What is the effect of aliasing on a digital oscilloscope caused by setting the time basis too slow? A, excessive blanking occurs which prevents display of the signal. B, all signals have DC offset. C, a false jittery low frequency version of the signal is displayed. D, calibration of the vertical scale is no longer valid. And the answer is C, a false, jittery, low frequency version of the signal is displayed. What is the impedance? What impedance does a 1/8 wave transmission line present to a generator when the line is open on the far end? A, capacitive resistance. B, inductive resistance. C, infinite resistance. D, the same as the characteristics of the impedance of the line. So a, a transmission line gives a capacitive or inductive resistance depending on whether it's open or not. And I am going to say if it's open, it's going to be a capacitive resistance. And that is correct. How does the performance of a horizontally polarized antenna mounted on the side of a hill compare to the same antenna mounted on flat ground? A, the main lobe takeoff angle increases in the downhill direction. B, the horizontally beam width decreases in the downhill direction. C, the horizontal beam width increases in the uphill direction. D, the main lobe takeoff angle decreases in the downhill direction. I'm going to say because the downhill direction has more I'm not going to go into that explanation because it's not accurate because I guessed A and that's not right. So the answer is D. The main lobe takeoff angle decreases in the downhill direction. Let's read the explanation for that. The performance of a horizontally polarized antenna mounted on the side of a hill will be different from the performance of the same antenna mounted on flat ground. And there is no explanation. They're just reiterating what the answer is. So that's somewhat disappointing. See what. And I am so I'm doing a web search for the E3C10 because that's the section number. And I am getting last year's, or so the test questions are good for 4 years. And this batch of test questions that we have right now is good starting in middle of 2020 through 2024. And the one the answer that I just looked at is was for the previous question pool. So amateur, see if I can fix. And all of these there. That's one that should. The radiation, so this is a slide from someone giving the slide for someone doing class, and says the radiation pattern of a 3-element horizontally polarized beam antenna will vary with the height above the ground. And I know that, but that isn't what the question. And then it just says a performance, and then it just again says the performance of a horizontally. It just again just reiterates what it says. It doesn't give a better explanation, unfortunately. So okay. Which VHF amateur bands have frequencies authorized for space stations? A, 2 meters and 1.25 meters. B, 6 meters and 2 meters. C, 2 meters. D, 6 meters, 2 meters, and 1.25 meters. I'm going to go with 2 meters because that's the only one people hear about. And I don't know. And we will find out if it's the only one we hear about because that's what they use or if the other ones aren't common. Okay, they are authorized. C is correct. 2 meters is the only one that they are only VHF frequency they are authorized to use for space stations. So, what is the time constant of a circuit having two 220 microfarad capacitors and a 1 megaohm resistor all in parallel? A, 440 seconds. B, 55 seconds. C, 220 seconds. D, 110 seconds. And I do not have a clue, so I'm going to guess D. And the answer was C, 220 seconds. So the time the time constant equals the resistance times the capacitance. So with this circuit containing two 220 capacitors and 1 mega ohm resistor all in parallel, the first thing to remember is capacitance in parallel increases and resistance in parallel decreases. So the total resistance, because the total resistance is half a mega ohm because the two divide each other out. Divide the total is divided. capacitors add, so that is going to be a total of 440. And because it's mega ohms against picofarads, it's going to be 0.5 times 440, which would give us the 220 seconds. What is the phase angle between the voltage across and the current through a series RLC circuit if XC is 500 ohms and the resistance is 1 kilo ohm, and R is 1 kilo ohm, and XL is 250 ohms. A, 14 degrees with voltage lagging the current. B, 14 degrees with the voltage leading the current. C, 68.2 degrees with the voltage lagging the current. D, 68.2 degrees with the voltage leading the current. And this one will be uh, I'm just going to pick the first one. The first one's correct. So the answer is 14 degrees with the voltage lagging or following the current. Let's see what. So the phase angle is the arc tangent of XC minus X, or XL minus XC divided by R. So that would be 250 minus 500. So that's a negative 250 divided by 1000. And because it's a negative, it's going to be lagging. What does the receiver noise floor of negative 174 dBm represent? A, the minimal detectable signal as a function of receiver frequency. B, the noise figure of a 1 Hertz bandwidth receiver. C, the theoretical noise in a 1 Hertz bandwidth at the input of a perfect receiver at room temperature. D, galactic noise contribution to minimal detectable signal. I'm just going to go with A because I don't have a clue. And looks like C is correct, which this would be another one of the longest answer is correct. C, the theoretical noise floor in a 1 Hertz bandwidth at the input of a perfect receiver at room temperature. So let's see if they have anything. And they say the hint is room is in the answer and floor is in the question. My thought is negative 174 dB is not something that most receivers are gonna it it doesn't look it doesn't it isn't in the range that you typically talk about. Um, you're normally talking about like like maybe plus plus 10 dB or minus 10 dB. So it's something that would be more of a theoretical number. So that's what I would need. That's what is probably what I'm going to use in my mind to remember it. Why is, and we had this one already. What is, which of the following is an advantage of using antenna analyzer compared to SWR bridge to measure antenna SWR? A, all of these are correct. B, antenna analyzers do not need external RF source. C, antenna analyzers display in a time varying representation of the modulation envelope. D, antenna analyzers automatically tune your antenna for resonance. Well, D isn't correct because antenna analyzers don't tune. So that means A is not correct. And I'm going to go with B because that is the one thing about my Nano VNA that I like is I can just hook it up and I don't need my radio to provide a RF source. And B is correct. Which of the following which of the following does the performance of a horizontally polarized, and we get this one already. There we go. For which types of out-of-pocket expenses do the Part 97 rules state that VEs and VECs may be reimbursed? A. Providing amateur operator license examination preparation training materials. B. Teaching an amateur operator license examination preparation course. C. Preparing, processing, administrating, coordinating, and examination for an amateur radio operator license. D. No expenses are authorized for reimbursement. Well, I know D isn't correct because we pay $15 a fee for $15 that is going to the VECs for reimbursement. Um, and A and B isn't correct because the VECs where they can do studying um, and they can do that, it's not part of their what Part 97 gives. It's not part of what they do. It is something that people do as an extra independent of being a VE. You can, like this training that I'm doing right now is not part of, I am not a VE yet. I probably will be once I get my amateur extra license, but I am not. So that is not part of training and um, teaching materials is not part of what a VE does. So it is, I'm going to go with C, preparing, processing, administrating, and coordinating the examination. What must be done before placing an amateur station within an officially designated wilderness area or wildlife preserve or an area listed on the National Register of Historical Places? A proposal must be submitted to the National Park Service. B, a Form SD-15 must be submitted to the Department of Interior. C, an environmental assessment must be submitted. D, a letter of intent must be filed with the Environmental Protection Agency. And since this is all our stuff is done by FCC, I'm going to go with the one that deals with the FCC. So, and that is correct. C, an environmental assessment must be submitted to the FCC. What is the name of the process that shows that a square wave is made up of a sine wave plus all its odd harmonics? A, Fourier's analysis. B, vector analysis. C, numerical analysis. D, differential analysis. I don't think it's C or D. Maybe I'm wrong. I'm just going to guess A. And A is correct. Let's see if Fourier's analysis allows for time domain signal to be transformed into the frequency domain, letting anyone determine what frequency components exist in the signal. They have a hint, and I don't know. Squares have four Fourier sides, and I don't. Oh, because it's a square wave. Maybe. What is admittance? And the A, the inverse of the Q factor. B, the turn ratios of a transmitter. B, the turn ratio of a transformer. C, the inverse of impedance. D, the term for the gain effect. And I'm just slaughtering things today. Let me start over with D again. D, the term for the gain of a field effect transistor. And impedance is the resistance and the stopping of things. And so admittance is the opposite of that. Is letting something through. Why are switching amplifiers more efficient than linear amplifiers? A, linear amplifiers have high gain resulting in higher harmonic content. B, power transistors is a saturation or a cutoff most of the time. C, switching amplifiers use push-pull circuits. D, switching amplifiers operate at higher voltages. Oh, I'm thinking it's either B or C, and I'm just going to guess B. Oh, B is correct. Um, this is an ideal switch when closed has 0 ohms of resistance and when open has infinite ohms of resistance. In either case, the switch does not generate any heat or loss. Transistors and switching amplifiers act like a switch. They're on or off, either open or closed, and therefore do not generate much heat, which is the heat is the less heat something produced, the less loss and the more efficient it is. What is frequency division multiplexing? Welcome to those that are watching. You are free to comment. You are free to click the link that is pinned at top and join us in StreamYard and uh, ask questions and go through and just check out the amateur extra study questions that we are going through on hamstudy.org. What is the frequency division multiplexing? A, the transmitted signal jumps from band to band at a predetermined rate. B, transmitted signal is divided into packets of information. C, two or more information streams are merged into a base band, which then modulates the transmitter. D, two or more information streams are merged into a digital combiner, which then pulse position modulates the transmitter. Oh, I am going to. I'm going to guess. I don't know. I'm thinking either C or D. Let's go D. Since it's the longest one. Nope, it was C. Two or more streams are merged into a baseband. Okay, so that's how I'm going to remember it. It's just the fact of multiplexing is sort of is dividing up the frequency so that things can get merged together. Um, see what the answer. See what the explanation says. Oh, in frequency division multiplexing, a communication medium is divided into non-overlapping frequency subbands, which can be used independently to independently transmit separate information streams or dependently transmit a single information stream in parallel. Although a technically correct answer, the option looks at the question from the reverse of the way that frequency division multiplexing is normally thought of. From the result, which is that the frequency band has been divided into separate streams with each stream carrying part of the overall message. Describing it as two or more information streams merged into a baseband, which then modulates the transmitter, is intended to be confusing, but it's technically accurate. None of the answers appear correct, especially if you are already familiar with encoding techniques from data modems. Remember that this question requires reversing the thought process. Ignore the name of the method and realize that the way you get to the end result is first splitting the information being sent. Okay, confusing. Yeah, I'm going to go with what I originally thought of my way of and maybe my way of thinking is inaccurate, but it's what I'm going to use as the dividing the frequency is used for so that things can get merged together. So that's um so that is what that's the things that I'm going to use as my key hint. So next question, and we got this one already. What does the receiver noise floor of negative 174 dBm represent? And negative 174 dBm sounds theoretical to me. So I'm going to take the theoretical answer of D, the theoretical noise in a 1 hertz bandwidth at the input of a perfect receiver at room temperature. It also is the longest answer. How does the performance of a horizontally polarized antenna mounted on the side of a hill compared with the same antenna mounted on flat ground? And I'm going to go with, and I believe it's, since we've had this question already tonight, I believe it's A, the main lobe takeoff angle decreases in the downhill direction. And unfortunately, they do not have a good explanation of this one, which is what I was looking for before. With your transceiver displaying the carrier frequency of phone signals, you hear a DX station calling CQ on 3.601 megahertz lower sideband. Is it legal to return the call using lower sideband on the same frequency? A, yes, because the DX station initiated contact. That is wrong. It doesn't matter who initiates contact. You have to stay within what your frequency permissions are. B, yes, because the displayed frequency is within the 75-meter phone band segment. That is not correct because it does your the displayed frequency does not matter. It is what where your signal is actually going out on. So if you are going on lower sideband, it is on the lower side of the displayed frequency. Upper sideband is on the higher side of the displayed frequency. It doesn't matter what the displayed frequency is, it matters what signal is actually going out. C, no, US stations are not permitted to use phone emissions below 3.6 3.610 megahertz. D, no, sideband will extend beyond the edge of the phone band segment. So these are both possible. I personally do not know what the lower limit for the they say 75-meter phone band. I'm sometimes I think it's referred to the 80-meter. I'm not specifically sure what the where the band limit is. So since both of these would so if this is correct, then this is also correct because if we aren't allowed to um, use phone emissions below 3.610, then the sideband will extend beyond the edge. So since if this is correct, this one's also correct, then this is the only one that then D is actually the only one that can be correct because you can't have two correct answers. So I'm going to go with D. Maybe a convoluted way to get there, but that's how I come up with the answer. And it is correct. D, no, the sideband will extend beyond the edge of the phone band segment. What one way What is one way of a single sideband phone signal can be generated? A, by driving a product detector with a DSB signal. B, using a loop modulator followed by a mixer. C, using a reactance modulator followed by a mixer. D, using a balance modulator followed by a filter. I am actually going to go with D. By using a balance modulator followed by a filter. And that is correct. And why I chose that one is the a single sideband phone signal is actually an AM signal. So that's the balance modulator that is then sent through a filter to remove the main signal, the main carrier signal, and the other sideband. So for the previous question, we had the question of the lower sideband. When it sends out a lower sideband, it takes the AM signal, which is has data on the main carrier and then the upper and lower sideband. It takes off the data on the main carrier and the upper sideband and sends the data only through the lower sideband. So that is my understanding of how it works and why I chose the answer that I did. What is the half power bandwidth of a resonant circuit that has a resonant frequency of 3.7 megahertz and a Q of 118? And I am not really sure about this one. So I am going to, oh, um, I'm just going to pick the 15.7, and I'm wrong. And the answer is 31.4 kilohertz. Let's see what they have for the explanation. Bandwidth half power in megahertz is the resonant frequency divided by Q. So if you were to take, and I am pulling up a calendar and not my calculator. There. So 3.7 divided by 118, and you get 0.0313. So, yep. So that's so yeah, just divide the megahertz by the Q. Quick, memorize, you have to memorize which formula it is, but it's a quick answer. Where must the carrier frequency of a CW signal be set in order to comply with FCC rules for 60-meter operation? A, at the lowest frequency of the channel. B, at any frequency where the at any frequency where the single sideband are within the channel. C, at the center frequency of the channel. D, at the highest frequency of the channel. I am going to go with B, since CW signal is smaller than the single sideband signal. So anywhere that a single sideband is permitted, the CW channel should be permitted. And I'm wrong. So it so CW actually goes on the center of the carrier frequency. So it is C at the center of the frequency of the channel. And yeah, um, all signals transmitted by an amateur on 60-meter channels must be centered within the channel. For all those watching and watching the replay, please like the channel if you haven't already, and like or subscribe to the channel, like the video, and hit the notification icon to get notified when I go live and post additional videos. And we are just over the 7 o'clock or 6 o'clock, 7 o'clock Eastern time frame. So I am going to have this be the last question. And I think I heard something about maybe Red Summit RF or HF, or I don't remember exactly, has a video tonight. So head on over there and watch his video if I am correct, which I do not know if I am. Which of the following noise figures value is typical in a low noise UHF preamplifier? I am going to go with 10 dB. And I am wrong. It is not negative 10 dB. So the answers are A, negative 20 dB, B, 44 dB. So negative 20 dBm, negative 44 dBm, C, which is negative 10 dB, which I was wrong, and D, 2 dB. And the answer is D, 2 dB. Noise figure is a ratio between the noise of the receiver produced and the theoretical minimum. Since it's a ratio it is measured in dB, and thus we can eliminate both figures given in dBm. Since this is real world, the ratio is strictly positive. We can't have negative values. Only remaining answer is 2 dB. So thank you for all those that watched us tonight, and thank you for all those watching us on the replay. And have a good evening, and hopefully you will join us on a future live stream. Thank you. Take care.